Hi, in this video we will learn when a 2 by 2 matrix is invertible and what is the inverse of the matrix. Well, as we learned before, checking invertibility of matrices, unlike checking invertibility of numbers, is not an easy task. But this thing, in case of 2 by 2 matrices, is a straightforward job. So let us start with a 2 by 2 matrix. So if I have A, B, C, D. Yes, then we can create this matrix. This matrix is, well, switch the entries on the main diagonal, interchange those ones, and multiply the off-diagonal entries by negative sign. Well, this matrix, if you multiply this with the original matrix A, so let me start with this A. So if I multiply A, let me D, negative B, negative C, A, to A, B, C, D, what you will notice is that, okay, so here, the first row, first column, gives us AD minus BC. First row, the second column is DB minus BD. And this guy here, the second row first, this is minus CA plus AC, and the second row here, this gives us AD minus BC. And as you can see, well, these two guys are 0, and we can factor out this AD minus BC part, and we get identity here. So multiplication of these two matrices is not equal to identity, but a multiple of identity. So if that identity is non-zero, so AD minus BC is non-zero, then we can multiply to the other side and get this thing. So 1 over AD minus BC, D minus B minus CA, then you multiply to matrix A, B, C, D. This will give you the identity matrix. Uniqueness of the identity, where the inverse matrix says that, well, this guy is the inverse of the matrix. Okay, so this is the theorem, actually. Theorem. So at least we showed this thing that matrix A, B, C, D is invertible if AD minus BC is non-zero, and in this case, then the inverse is 1 over AD minus BC, D minus B minus CA. Well, theorem actually has more to offer. What about if AD minus BC is not is equal to 0? Well, the theorem actually says that if it is equal to 0, then the matrix is not invertible. So in other words, this is if and only if. What we showed was that if this guy is non-zero, then the matrix is invertible, and that's the inverse. The other way around, you need a little bit more work. You can check the book, but it's not difficult to check. You have to separate different cases, but at the end you'll see that the other way around is also true. So checking invertibility of 2 by 2 matrix is just checking that AD minus BC is 0 or not. Okay, let's do just one example here. Maybe paste. Okay, so for this one, we first start with this AD minus BC case. This is -2, non-zero, so that means that it is invertible. So in this case, the inverse is going to be 1 over -2. Interchange the entries on the main diagonal, multiply off diagonal entries by negative number, negative sign. Yeah. So if I can just move this one here, then the inverse is basically half of that negative half. That's -2, 1, 3 over 2, -half. This is the inverse. For the second one, well, the 2 times 6 minus 3 times 4, this is 12 minus 12, this is 0. As a result of the theorem, the matrix is not invertible. And well, that's what we have. Well, we can have different questions like this one also. When, for what values of k the matrix is invertible. So A, here's k, times D minus a -1 B times C. It is invertible if this guy is non-zero. So that means that k2 minus 3k plus 2 is non-zero. Well, being non-zero is what? It means that you are not equal to 0. So if you find the 0 thing and exclude those ones, this will give you where the matrix is invertible. For what values of k it is invertible. So here I have -1k minus 2. You can decompose that, and as a result of this means that k is for not being invertible. So for being invertible, k needs to be not equal to 0, and k needs to be not equal to 2. Well, this task for higher dimensions, we need more thing to learn about that. We will see how to find those ones, and it's not usually easy as 2 by 2 matrices.